All right. So let's say I got some kind of pool where you can see the side of the pool is a trapezium. Side of the pool is a trapezium. That side is parallel to this side, and that's the deep end. This is the shallow end. Let's say the shallow end is roughly around 1 meter, and the deep end is roughly around 2 meters. And the length of the pool is 4 meters this way, and maybe 3 meters this way. And we want to calculate how many liters. There's so many things that we can get from this. So I'm going to go randomly into this, but these are the ideas that you can keep in mind when you're doing these questions here. All right, so let me just label this quickly over here. So you got your trapezium. Do you know the formula for the area of a trapezium?
I've written down some.
All right,
It's like half and then bracket a plus b times height.
that's it. So this a plus b will be the parallel sides always. So if I want to work out this area, which is known as your cross-sectional area, this is a cross-sectional area because it's the same area that if you slice this like this, you'll have the same shape, that trapezium all the way through. So this is your cross-sectional area. And that cross-sectional area, this is going to be your A, that's going to be your B, and this is going to be your H, right? This is going to be your H, which we said was 4 meters. And the H, you notice it's 90 degrees to the A and the B. This is not the H. That's a slant height, right? So if I want to find this cross-sectional area, it's going to be given by half, because it's a trapezium, A plus B times H. In this case, H will be that over there. So that's going to be half of 1 plus 2, which is 3, and then multiplying that by 4. I'm going to bring the 4 and the 2 together. It becomes 8. That becomes 2, sorry. 4 divided by 2 is 2, and 2 times 3 is 6. So this is 6 meters squared. Let's say the depth of the pool is given as 3 meters. And this is how, now we know depth goes down, right? Normally, this is actually the real word of depth, right? But if in volume, we take the cross-sectional area and we multiply it by a third dimension, because we're taking that cross-sectional area towards that third dimension. We're taking that area and we're pushing it outwards towards this, in this direction. In this direction, we're moving 3 meters from there. So that will be my, what is known as depth, but it's not actually depth. We're just going to call it the third dimension. So the volume for this, that this pool can house, the volume that this pool can house will be given by the cross-sectional area. I'm going to call it CA, multiplied by at 3 meters, which is how deep the shape has gone, or we can write there the third dimension, basically, where volume is always in 3 dimensions, meters cubed, right? So this is going to be 6 meters squared. And then I multiply this by 3, which becomes 18 meters cubed. Okay? What did I do now? I got my volume, and now I can work out how many liters. Now remember, we said 1 meter cubed is the equivalent of 1,000 liters. So 18 meters cubed is going to be given as 18,000 liters. Now let's say we have a budget. All right, we have a budget at the moment of let's say we have a budget of roughly 8,800 and let's make it 9,000. Let's say I got a budget. Okay, 8,800. $8,800 is the budget that I have on a monthly basis to fill up water in the pool, because it's a public swimming pool, so people are swimming, so we need to empty the water and get clean water in there. So to do that, I need to calculate how much this will cost. And let's say the cost of water Auckland at the moment is at $0.5 per liter. All right, so that's a rate. I'm going to take those two and I'm going to multiply them. If I take 18,000 times 0.5, it's half. So it's going to come to $9,000 but my budget is 8,800. So therefore, I can see that this is under budget. Can you see that? It's under budget by $200. Okay.
Yeah.
All right. So we have a lot of things that we've worked out here already. The first thing is put some headings in, make sure that you have full sentences as well with conclusions, and you have your units in place as well as your correct answers. We're calculating an area, we're calculating a volume with the units, state that it's the volume. We're also doing a conversion over here. All right. There's another conversion over here. And then we're using rates as well. At this juncture, and also putting a conclusion that you're under budget, you're done with the internal if you can do that so far. Now the shapes, remember, can change. This can be a trapezium, this can be a cylinder. All right, but the concept will be the same. It's area multiplied by that third dimension over there, or depth, right? And you can also do it with a triangular prism. Calculate the area, cross-sectional area, multiplied by depth. Or you can do it with any shape. It could be a block, even like this. Work out this area multiplied by depth. And in each case, you'll get the volume. So that's the area and the volume calculation, the first two parts. Capacity, remember, this is the conversion that we need to use. 1 meter cubed is equal to 1,000 liters. And that's what we would use to calculate that. Okay, now that I have that, got my budget, etc., I now want to include maybe a bit of a perimeter question in here. So I now create some tiles across here. All right, so I got some tiles across here. And these are extending all the way through here like that. And let's say the tile is roughly around 0.5 meters, okay? So 0.5 meters from there to there. And we want to know how many tiles, if each tile is a block of 0.5 meters, okay? And let's say one tile costs roughly $12.50. Okay, so one tile costs $12.50. And I want to know how many tiles that I need for this. Okay, so looking at plus minus, do I have a budget for this? Let's see. Let's say my budget for tiles is $300. So if my budget is $300 for tiles, how many tiles can I fit? Work out the number of tiles. Once you've worked out the number of tiles, then take the number of tiles and multiply it by $12.50. Work out the number of tiles and multiply it by $12.50. And that will give you the total cost of the tiles. So the first thing we need to do is find out the number of tiles. Because this is half meters, remember that if I put a block over here, it's going to be 0.5 meters on either side. Therefore, if I got 4 meters from there till there, how many tiles can I fit? I can fit 8 tiles, right? I can fit 8 tiles because 8 divided by 2 is 4. Half a meter, right? Each. So 8 tiles will run this way, from there to there. And this way, I would have 6 tiles. Can you see that? So I got 6 tiles running this way, and I've got 8 tiles running this way. 8 plus 8, so the number of tiles is going to be calculated by taking 8 this way, plus another 8 over here on the other side, plus 6, plus 6 on the other side as well. But we excluding the corner tiles, right? Do we want to include the corner tiles? Can you see that we have these 4 corner tiles as well? I think we should include the 4 corner tiles because it's somewhere you can walk around, so it will help you to walk around. So it would be good to include that and then state that you're going to include the 4. You would state including, so this is plus 6, 2 sixes, including 4 corner tiles comes to how many tiles in total? What will that add up to? So that's
32, isn't it?
32. Yeah. So that's 12, and 16 is 28, and 32. So 32 tiles. Definitely. Now we take that. Let's multiply that by $12.50 per tile. What does that come to? 32 times 12.5. $400, right?
400.
All right. So do we have a correct budget for this? No. We are
Now we
under
100.
again. We're going to state that again. So we state that in a nice full sentence. We are under budget by $100, subtracting the two. And we also got to state that we're including that four tiles because it will look better and it will also be helping you to walk all the way across. But if you can remove the tiles, it will still cover the perimeter. So what have you calculated over here? You've calculated the perimeter, right? You've calculated the perimeter, which is going to be 3 plus 8 plus 6 plus 8 again. And you're adding the four tiles, so there's a perimeter mark here. And then there's another question where you have to now multiply it by the cost per tile, okay, which will take you back to the achieved section. And then that's more or less in conjunction with what you would have. In excellence, you could state maybe question the entire question and say maybe zero point 0.5 meters is too small. Maybe you need 1 meter length. So if you extend it to 1 meter length, then what will happen is you'll have to probably put double tiles in there. And if you put double tiles in there, what will the cost change to? And what will the budget need to be? For example. All right. So that's an idea of that you can possibly get. And that's pretty much the gist of it.